Hi, this is Craig Stocks here for Utah Desert Remote Observatories. You can find us online at utahdesertremote.com. And today we're going to be looking at some data that was captured for a client doing the rental by the hour. And he normally had been doing color imaging, and he wanted to try monochrome RGB plus narrowband. So we're going to be going through his target with his permission and look at how I will process this target using RGB plus SHO data using PixInsight and Photoshop. The target that he chose was the Rosette Nebula, and you're probably most familiar with seeing the Rosette Nebula in color. This is just a simple RGB version of it. It's a very bright emission nebula with a lot of oxygen in the center and then hydrogen and sulfur around the perimeter. This is just a simple RGB image, but he wanted to try narrowband. And the advantage of narrowband is by selecting just individual gases, you can resolve more detail and you can also create more color contrast. So this is that same region, same framing, but with the narrowband data. So we're going to create an image that looks more like this using narrowband data from a monochrome camera. So to do that, we will start in PixInsight, and I should have cleaned this up before I started, so let me just do a quick close all and get all of this out of the way. So now we have a blank screen to start with. Now, I have already run the data through WBPP, and I've also already kind of screened the data. I screen the data by going to Process Image Inspection Blank, and I will select the folder where his images are stored, which should be right here. And this was just imaged last night, and just select all frames and open those, and this will give you a quick preview, so it's something that you can go through very quickly. A lot of people, the reason it's called blink is a lot of people will blink through them one by one, and that's also a good way to spot, for instance, comets or asteroids that are moving from frame to frame. I use it just to go through and remove any frames where maybe the wind blew or clouds moved over, or for whatever reason the subs aren't as good. So you basically are just looking for sharp round stars and step through the images and remove any from the folder that aren't up to par. Once I've done that, let's look at the way I would configure WBPP. So to do that, we would go to Script, Batch Processing, Weighted Batch Preprocessing. And I'm not sure what the last state of this is, so we'll just start from scratch. So it looks like it's still configured. No, we'll start over. So I'm just going to do a reset and from the current settings and clear all file lists. And PixInsight used to remember these settings from session to session. It does not anymore, so you have to click this each time you do a reset. So the first thing we'll do is go to the Lights tab, and we need to use the plus Lights button to add lights or light frames. And basically I send all of the light frames to the client using Dropbox. So they'll get a Dropbox transfer. They can download, extract the files, and then store those in a folder on their computer. So there are all of the light frames, red, green, blue, sulfur, hydrogen, and oxygen. Then we also need to load the calibration frames, and this is something I also would send in a separate transfer. And I find it easier to just keep a directory of my calibration frames that I'm currently using, so I can load all three sets at once. So I would go to Directory, And what this is doing is loading an entire directory. And in my Astro folder, I have a calibration folder, and this is the mono data combined. So select that, and it's going through folders and subfolders within that directory and finding all of the frames that it knows what to do with, and it puts them on the appropriate tab. So now we have our bias frames, our dark frames, and our flats all loaded and ready to go. So now let's just look quickly at the settings on the calibration, or I'm sorry, on the lights tab. I'm using PSF signal weight as the sum frame weighting. Image registration, if we click on registration parameters, you can see I'm using bicubic B-spline rather than auto. I find I get more consistently well-registered data using bicubic B-spline rather than auto. So that's something that you might want to consider changing. And then astrometric solution is checked. Linear normalization is not checked. I find I don't need that. And then, of course, image integration is checked, and this is where you tell it that you want it to do. And here I'm just using the defaults for image integration. So WBPP, I believe, started just doing calibration, and then the integration step was added later. If we look at the calibration tab, this shows our bias frames, our darks, our flats, and then our lights. And we can select any one of these rows in any one of the groupings, and when we do, we'll get settings in the center column that we can adjust. So if I select one of the light frames, for instance, if we look at the output pedestal, it's currently set to 0, and I'm going to change that to automatic. Calibration settings, we just have the darks and flats as auto. These are monochrome images, so we don't need to do anything with the CFA settings. In fact, you don't want that checked because these are all monochrome data. So this is one of the differences between processing mono and processing color, or CFA, which stands for color filter array data. The last thing we need to do is come over to the registration reference image selection, and we want that set to auto. And then we just choose an output directory where PixInsight is going to store all of its working files. And I just have a temporary folder set up as PI swap files, and I would just choose the Rosette for gem. And okay, so now that's where all of the working files and the resulting master files are going to be stored. Once this is configured, you would just click Run, and it'll give you a quick check. We have enough working space, and I always get this warning that it can't handle files with a path longer than 256 characters. I know that, and I know that's not a problem, so I just haven't taken the time to make the fix in Windows to get that error message to go away. So at this point, you would just click Continue to get it to start. I've actually already run it, so I'm going to click Cancel. And once it's done, we can close the WBPP window, and now we're ready to start processing the images. And if you remember, I said we captured red, green, and blue, plus sulfur, hydrogen, and oxygen. And there's a couple differences in processing monochrome data versus color data. If you're still looking for an RGB color image, you would do this first step the same way, and then we're going to also come back and process the narrowband data. So the first thing I want to do is open the red, green, and blue data. And if you're not real familiar with how mono works, what we've done, we're using a monochrome camera, and the filter wheel contains red, green, and blue filters. So we capture sets of data for just the red filter, just the green filter, and just the blue filter, and that's how we get natural color. So in the master folder, we have master lights, and we have reds, greens, and blues, and then you can see we also have hydrogen, oxygen, and sulfur. We'll come back and work with those in a minute. So I want to open all three of these, and these will open as grayscale monochrome images. As I said, one for the red filter, one for the green filter, one for the blue filter. With a color camera, the individual pixels would have either a red or a green or a blue filter, and that's how it collects red, green, and blue data in one shot. But then it has to go through a process called demosaicing, where it takes those individual reds, greens, and blues and interpolates the missing values based on the neighboring pixels, so that you wind up with red, green, and blue values for every pixel. With the monochrome camera, we get that red, green, and blue values for every pixel by using a red filter, a green filter, and a blue filter. So if we just do a quick screen stretch to look at the red data, this is what it looks like. If we look at the green, it's a little different, and then this is the blue. And what we want to do is just combine these three, red, green, and blue, into one RGB image. And we're going to do that using the channel combination process. So go to Process, and All Processes, Channel Combination. And I'll just use the star down here to reset it. And what we want to do is we want to put the data captured with the red filter and tell it to use that as the red channel. So we just come over here and select the image that has the red filter, and then we do the same thing for the one that has the green filter, and then lastly we select the blue filter. So now we have red, green, and blue correctly assigned to the red, green, and blue channels. Click the filled in solid circle to apply this, and it will create a new RGB image. And if we do a quick screen stretch on it, you can see that we now have a color image. It'll almost always have some color cast to it, but we've got a color image. And in fact, we're done with the red, green, and blue, so we can just close these. And now we would process this just like you would if you were using a color camera. So that one step of using channel combination is really the only difference between a color camera and a monochrome camera for the RGB part of it. The next thing, we're really just after stars here, and we are going to want natural RGB star colors. I mean, that's part of the reason you would shoot RGB when you're doing narrowband, is to get RGB, good colors of stars. So the first thing I'm going to do is do a blur exterminator with correct only, and I've got this process saved over here as a process icon. You can create that by just going to Process, All Processes, and Blur Exterminator. There we go. Make whatever changes you want to make. In this case, it would be correct only. Drag this out from the triangle as a saved process, or as a separate process, and now we can edit the instance description, edit the icon identifier, and name it, or whatever you want to name it. And then I usually drag it over here and save this as a blank project. So I just open the blank project and it loads all of these shortcuts for me. Since I've already done that, I'm going to use some of these shortcuts that I've already saved. So once it's saved, I can just grab that saved instance, drag it onto the image, and now it's going to run the Blur Exterminator in a correct only mode. If you don't have Blur Exterminator, you can just skip this step. What it's doing is it's going to tighten up the stars a little bit, and it will make it a little bit easier for color calibration to identify the stars. I haven't run personally a back-to-back test, but the reviews have said that by doing this, it allows the color calibration to identify more stars, since there's more of them that have nice, neat, tidy shapes. Blur Exterminator really does a wonderful job of identifying the various aberrations or convolutions that you might have from misshapen stars, and applying a deconvolution algorithm to correct that. Visibly there's not much change here. So now we can use the spectrophotometric color calibration, And again, I have a saved instance that is set up for the monochrome camera with these filters, and I can apply that by just dragging it onto the image. You can also get to spectrophotometric color calibration through the process menu. This one does take some setup. There's a Gaia database of the stars that you need to download, and it's a bit of a process. There's a lot of documentation online. Basically, you download the Gaia catalog that you need and extract it from the zip files that it comes in, and then save it somewhere on your hard drive. Then you have to go tell PixInsight where you installed that database of star information. And there's actually two Gaia catalogs. There's one that's used for plate solving, one that's used for color calibration, and they're both Gaia catalogs, but they're different and they're not interchangeable. So this is finished, and I have it give me a little report that shows me how well the selected white balance matches the Gaia star colors. And if we update the auto stretch, we should see now we have a nice natural color image that got rid of that color cast, and the stars should have colors now that closely match their true colors based on the star's composition. Now I would typically run Blur Exterminator just in its normal mode. Since there's a lot of stars here, I will usually run, in a situation like this, I would run Blur Exterminator in what I call a more aggressive mode. And again, I have these different versions saved, but what the aggressive mode does is it turns up this sharpen stars setting from its default of, I believe, 20 up to 35. So it's a little bit more aggressive in how it sharpens the stars, which in effect, as you sharpen a star, that diminishes the star. And part of our challenge with this is going to be to reduce, minimize, or eliminate a lot of these little tiny stars that just appear as noise and block our view of the nebula. So this usually takes about 45 seconds, I think, to run. It used to run in 15 seconds and then 30 seconds, and now it's, as they keep improving it, it does a little bit more work and it takes a little bit longer, but still, not a problem at all. Again, if you don't have Blur Exterminator, you can skip this step. I do highly recommend Russ Croman's RC Astro plugins. So the next thing I will do is stretch this image. It's still in its linear state, and the little green bar over here by the image name tells us that we're looking at a screen stretched image using the screen transfer function. And I'm going to create a nonlinear version of this, but I'm going to use the screen transfer function to do it. And I'm also going to use the histogram transformation tool to actually apply it. So we'll come to the screen transfer function first. The radioactive sign will calculate and show us what the screen transfer or auto stretch looks like. I will usually zoom in a little bit so that I can fine-tune these sliders. Since we're really after the stars here, I'm mostly going to darken it even a little bit more, which you'll notice as you darken it, the stars get smaller. So let's say something like that. And then to actually apply this to the image, we have to go through a little bit of a dance. You can use the triangle icon to drag the settings from the screen transfer tool down to the histogram transformation tool. And you'll notice now it has a curve in the transformation that it can apply. Now we can actually click either the square box or we can drag the triangle onto the image. And this will actually apply this, so we've now permanently stretched that image. And you'll notice the image turned white, and that's because we're still looking at the auto stretch, but we're auto stretching an already stretched image, so we're stretching it twice. To undo that, we can just turn off the auto stretch. Now that little green bar over here went away, and now we're looking at the actual stretched nonlinear image. So the last thing we want to do is run two more of the Russell Croman plugins, and that's Noise Exterminator and Star Exterminator. And we're going to use Star Exterminator with the option clicked to save the stars, so that we'll wind up with two images, an RGB starless image and an image of just the stars. And again, I'm going to do that with a shortcut that applies both at the same time. You can certainly also go through the process, go to All Processes, Noise Exterminator, and apply it. And the default settings work just fine for that. And then do the same thing with Star Exterminator. I just have a saved process container that does both one after the other. And I do have separate video that shows how to create these image containers that I occasionally use, and process containers. They're a good way to streamline your workflow. They don't make the computer work any faster, but what they do is they give the computer more work to do, so you have more of a break time. So rather than having to click a button every 15 seconds, maybe you can get 2 or 3 minutes before you click the next button. And that gives you time to go get a cup of coffee or check your emails or whatever it is you like to do. You might use that time to talk about what the system is doing while it's processing in the background. We still have a little bit of time to go, so what I'm going to do is pause the video here and I'll pick it up when the process container is finished. So Noise Exterminator and Star Exterminator have finished, and you can see we now have a starless image of the Rosette, and then we have a separate new image of just the stars. And typically what I do is I'll increase the saturation of the stars here. It's still in its most pliable state. It's still basically a raw image. So it's going to be more flexible now than it will be once we get it into Photoshop. And what I find is, even though these stars look pretty good here, once you put them on a more saturated background, they lose the appearance of saturation. So I usually use a simple process. I have a process container here labeled Enhance Stars, and it does two things. It applies a curves transformation with just an increase in saturation. And then secondly, it applies the SCNR, which will do a color reduction, and I have it set to reduce green. So sometimes when you increase the saturation, you get a little bit more of the cyan green halo around stars, so it reduces that. And to run that again, I'll just drag the process container onto the stars image, and you can see it boosted the color and also knocked out any green that we may have had. Now I can save these two files. So I'll just go to File, Save As, and I will now navigate back to the folder where I have the Rosette for Jim, and it's going to save it. Since it's a new file, it doesn't know what else, so it saves it as a TIFF file. And save this as a 16-bit TIFF. And I usually save the RGB file too, although we probably won't do anything with it. Sometimes it's fun to get both a color and a narrowband image out of the same data. Again, it's defaulted to TIFF. And we'll save this also as a 16-bit TIFF. So now we're done with the broadband color data, and we need to process the narrowband data. So I'm going to save these two down here in the corner, and it's time to open up the three narrowband images. And this is where it really departs from what you would do with a color camera. So again, I'll just double click on the background and go back to where our swap files are stored. And now we want to open the hydrogen, oxygen, and sulfur. And again, these are grayscale images, and in this workflow we're going to keep these as grayscale images. We won't add color until we get into Photoshop, and that's where we'll actually assign colors to the individual filters and create a full color image. So, to me, that's the fun part. And the processing here is pretty similar to what we did with the RGB image, and in fact we're going to do the more or less the same process with each one of these. So rather than going through and, for instance, running Blur Exterminator one at a time, we're going to create an image container so that we can, again, streamline our work. To do that, I will right-click on the background and choose Image Container, and we get this dialog box. And to add either files or views, and these are views because we have them open, I'll just select Add Views, and we want the 3 narrowband files, or views I should say. Click OK, and there they are. And I usually use the triangle to drag this out and create a process container, and then I can close this. So now this I said process container. This is an image container. So this image container represents all 3 of these images. So for instance, there's the sulfur, the oxygen, and the hydrogen with screen stretches on them. The first thing I'll do here is apply Blur Exterminator to these, and the focus now is going to be on cleaning up the nebula because we're going to take the stars out of these images. So I'll just come back to my standard Blur Exterminator with default settings, and I can just drag this onto the image container. And now PixInsight is going to go through sequentially and apply Blur Exterminator one by one to each one of the 3 narrowband datas. So I'm going to pause the video while it does its magic. So Blur Exterminator has done its thing on this image container, so we've now applied the deconvolution sharpening to each one of the 3 images. The next thing I'll do is stretch each one, and we'll do it the same way with the screen transfer function and the histogram transformation tool. So always start by refreshing the auto stretch, and you can also zoom in and out just by using the scroll wheel on your mouse. But what you need to make sure you're doing is position the cursor or the mouse pointer between the sliders so that as you zoom in, you're zooming in between them and expanding the view. And depending on the image, I may brighten or darken it, but because this is such a bright image, I don't want to blow out any of the data here in the core, so I'm actually going to darken the stretch a little bit. And then when I do that, I may have to lighten the background a little. And what I'm looking for here, I'm looking for the darkest areas to be very dark but not black. So let's say something like that. And this is our hydrogen data, and we do the same routine. Drag the triangle down to the histogram transformation tool, and then click the square to apply it. And I'm just going to leave it white so that I know I've processed that one. Switch to the next one, update the auto stretch, zoom in a little bit, and this is the oxygen. And it's always amazing how much and how bright that oxygen is there, especially in the core of the Rosette. I mean, it's a very bright nebula. Not as much going on around the perimeter, but the core has a lot going on. So again, drag the triangle down and stretch that one. Sulfur is last, and you'll notice between them, sulfur looks completely different. So the distribution of sulfur is very different from the hydrogen and oxygen, and that's what makes for an interesting picture. This one takes a little bit more of a stretch, trying to get a good distribution of tones from very bright to very dark, and try to avoid anything being pure white or pure black. And this is just with practice, you kind of gain a feel for what you're looking for. One thing to watch when you apply the stretch and the screen turns white, what I have found is when it's doubly stretched, if you see any areas that look black, that means they were probably too dark in initial stretch, so you might want to undo it and then go back and adjust it to be a little bit less aggressive. So now we'll just turn the stretch off for each one of these images just by clicking on each one and then unclicking the auto stretch. So now we are ready. They're stretched. These are now non-linear. You can see the green bar has gone away on the name tag, so we know we're looking at a stretched image. And now we want to do noise exterminator and star exterminator, but this time we don't need to save the stars. So again, I have a process container that has noise exterminator and star exterminator, and I want to apply this process container to this image container. So what PixInsight is doing for me now, it's going to go through the 3 images one by one, and for each one it's going to apply noise exterminator and then star exterminator. So it'll take it a couple minutes. It's about 45 seconds to a minute on each one, so maybe 3 minutes to go through the whole process. I won't make you sit here and look at me or listen to me for 3 minutes, so once again I'll pause the video until it's done. Noise exterminator and star exterminator have done their thing, and this is kind of the point where you get the first really good look at the data without the stars in the way. So this is the hydrogen file, and so again we need to save each one of these. So we'll go to File, Save As, and now we'll have to navigate to the folder where we have our TIFF files stored. And these are actually being saved as 16-bit grayscale images. And typically what I do after I save it is just minimize it, go to the next one, File, Save As, and again we'll have to navigate back to the correct folder, select TIFF as the file type, and 16-bit as the bit depth, and lastly the sulfur. And one of the really nice things that I like with the Rosette is that each one of the narrowband data files looks so different that with a little bit of experience you can almost just you remember by looking at them which one is sulfur, hydrogen, and oxygen, because it's very rich in all 3 gases, and each one is very distinct, and that makes it a good target for your first go around with narrowband data. You want something that's going to give you a lot to play with, and this really does. So again, here's our sulfur, there's the oxygen, and there's the hydrogen. So we're now done in PixInsight, and we're ready to go to Photoshop to process these. So I'm just going to switch over to Photoshop, and these are I'll just close this out of the way. And if you've watched any of my processing videos before, you probably know what I'm going to do next. We'll go to File, Scripts, Load Files into Stack, and you get this dialog box where you can list the files that you want to open. So let's go to Browse, and now we just need to navigate to the folder where we saved those TIFF files. And there they all are. Now this is a combination of RGB and monochrome. The 3 narrowband files are all stored in grayscale, so just a single black and white channel. And then the stars and the overall nebula were stored as RGB. Since some of the layers or some of the files that we're opening are RGB, Photoshop has automatically made this an RGB file. So this is a full color RGB file that we're working on with 5 layers. And we can confirm that if we go to Image Mode, we can see that the mode is RGB color, where if we had opened just the 3 narrowband files, it would still be opened as grayscale, and you would need to convert it to RGB color just by clicking on RGB color, and then Photoshop would convert the image mode from grayscale to RGB color. So there's our RGB color image, and I always start with a little bit of housekeeping. I will just drop this into a layer group by itself with Control G. That would be Command G on a Mac. Double click the group name and name it RGB. And I don't know if we're going to do anything with this at all, so I'm just going to drag it down to the bottom of the stack. Looks like the stars are next. So again, we're going to put it in a group with Control G, label it stars. And I'm going to put a levels adjustment layer and a hue saturation adjustment layer into that group with the image of the stars. And it's important that these two adjustment layers are in the group and not above the group. And at this point we can go back to the group level, so the group name, and let's change the blending mode to screen right here. And you can see with screen blending mode, the stars now show up on top of whatever's below. But for clarity, I'm just going to go ahead and turn off this group, and we'll turn it back on as we get closer to the end. So next is hydrogen. Again, drop it into a group, change the group name to hydrogen, and I'll just go ahead and click on levels, and that'll add a levels adjustment layer. And I know I want to darken the background down to something close to black, and you notice that the canvas or the background that I'm working on is currently set to black. You can change that by right-clicking in the canvas area, and you'll get a little pop-up that you can choose black, dark gray, medium gray, light gray, default, or custom. So black is one of the menu options. Default is however you have it set in your preferences for Photoshop, and I have that set to medium gray. And then for custom, you can select a custom color, and what I do for a custom color is select white. So now I can select custom to get a white background, black to get a black background, or default to get a medium gray background. And it's sometimes useful to look at your image against all three variations of background. And you'll find if it looks good against all three backgrounds, then you probably have the density about right. So let's go back to black, because here we want to compare the background of the image to the black background and make sure that it's not pure black. We'll turn off the hydrogen, go to oxygen, do the same thing, Control G, label oxygen. Since the group is open and I'm currently on the group name, when I click on the icon to add an adjustment layer, it will add it inside the group. And again, we'll just darken the background and then close the group. Come down to sulfur last. So now we have our three layer groups set up, and we have them kind of a preliminary adjustment for the overall brightness of each layer. Now we want to add color, and the classical color assignment for a narrowband image is called the Hubble palette, or sometimes called SHO. And the SHO stands for the order in which the colors are assigned relative to RGB. So SHO, S would be assigned to red, hydrogen would be assigned to green, and oxygen assigned to blue. Now, the reason you assign them that way is because those are the chromatic order of the colors in real life. So sulfur, for instance, is when it's ionized, it emits a very dark red color. So in fact, it's the most red of the three gases. So it goes into the red channel and gets a red color. Hydrogen is red and very close to the same color red as sulfur, but not quite as red. It's just very slightly on the green side of red. But in order to get more color contrast, we're going to assign it all the way out to green rather than letting it be the same color as the sulfur. That's how you get that color separation and color contrast to be able to see the individual structures. Oxygen, when ionized, emits a green-blue or cyan color, And again, we're going to shift it a little bit towards the blue and make it just blue. So the way to do that, and you'll see a lot of different approaches when you watch the various tutorials online. The way I do it, I think, is by far the easiest way to do it. Each one of these, remember, is actually an RGB image. So it looks monochrome, but it actually has a red, a green, and a blue channel. And each of those channels are the same, and when red and green and blue are equal, you get a neutral color or no color, so black, white, or some version of gray. Sulfur on the bottom layer here is red, green, and blue, so that's why we're seeing it as a monochrome image. If I come up and turn on the oxygen layer, it's also red, green, and blue, and it's essentially replacing, since it's in pass-through blending mode, it's replacing all the red, green, and blue that the sulfur is emitting with its own version of red, green, and blue. To make it a color image, we're just going to turn off a couple of those channels. And to do that, we want to go to the advanced blending options. You can get to that through layer style, blending options, and that brings up this dialog box. And since this is an RGB image, you can see here in the center of the dialog box, there are 3 check boxes for the 3 channels, red, green, and blue. If we want oxygen to be blue, all we have to do is turn off red and green, and now we have red and green coming from sulfur, and the blue is being replaced by the blue from oxygen. Now we can go to the hydrogen, and we can do the same thing, and the shortcut to get to that advanced blending options dialog is to double click on the layer or the layer group to the right of the name, and that'll bring up that same dialog box. We want hydrogen to be green. Click OK. And just like that, we now have our SHO Hubble palette image of the rosette with sulfur providing the red, hydrogen is providing the green, and oxygen is providing the blue. And you'll notice I didn't have to change the blending options for sulfur because it's on the bottom, and it's providing all 3. So it's putting out, if you think of it, it's putting out red, green, and blue. So if you think of this as being red, green, and blue, the red is the only thing making it through the stack because the blue gets replaced by the oxygen layer and the green gets replaced by the hydrogen layer. They don't always come out this good right off the bat, but since we already adjusted the levels in each one of these layers to make it a dark background, that gave us a pretty good head start. And so typically what you might want to do if you want to adjust the individual components, for instance, if we want more red in the background, we would go to the sulfur layer, to that layers or adjustment layer, levels adjustment. And if we, for instance, grab the brights side and move it in, that will increase the red component. So you can fine-tune the contribution of each one of these. We might go into the oxygen and do the same thing. We might want more blue in the center. And lastly, we might fine-tune the green. And the green combines with the other colors to turn yellow. So green and red turns orange, and if it's more green than red, it'll turn yellow. Let's come back. There's a fair amount of blue showing up here in the background. So we know blue comes from oxygen. So I'm going to just come back here and darken the black slider a little bit and get that background neutral. Typically, the last thing I would do would be to close these layer groups. And between hydrogen and the stars, we can add some global adjustment layers. And the ones I would typically add would be a levels adjustment layer. And notice since that layer group was closed, Photoshop added the adjustment layer on top rather than inside the layer group. And then maybe a color balance, a hue saturation, and We can adjust these individually. If we want to adjust the global brightness, we can use either levels or curves, either one. We can go to the color balance if we want to do some global color balance adjustment to fine-tune the colors. If we want to play with the saturation, we can do that with a hue saturation. If you want to target just an individual color, you can, instead of adjusting the master channel, we could go to the reds, for instance, and increase the red saturation. We could go to the cyans and adjust that saturation. If you want to include cyans and blues both, you can use these sliders to change the range that's selected. And you can see now we're really targeting this color here in the center. You might want it brighter or darker. You can even change the hue of the cyans and blues a little bit if you want. And then the last step, if you remember, we've got the stars layer up here on top. Let's turn it on. Now, to my eye, what happens when I turn these stars on is you lose the visibility of all of that beautiful detail that we captured in the nebula. So what I'm going to do is we'll open this up and we'll do a couple things. First thing we want to do, well, let me back up. The simplest thing to do is go to this levels adjustment, and because this levels adjustment is within a group and that group is set to screen blending mode, it's only going to affect the stars. So if I grab the midpoint of this levels adjustment layer and darken it, I'm making the stars darker, which basically just minimizes the stars. And you can see if you want them bigger or smaller, you just make them brighter or dimmer. And what you're doing is reducing the size of the perimeter around the stars. And in this case, that makes a pretty good adjustment. I would probably grab the hue saturation and increase the saturation of the stars. And frequently I'll find when I increase the saturation, it's not too much of a problem here, but the red stars start to get too red. So I will usually target the red channel in this hue saturation adjustment and reduce the red saturation to tone it back down. So we're mostly getting the blues and yellows. That's not a bad result. There are other things you can do that are basic Photoshop editing techniques in terms of sharpening, global color adjustments, and so forth. And that really gets into what do you want your image to look like. I would probably, if this were my image, I would probably darken it a little bit more. And I would probably bring the sulfur up brighter and get a little bit more of the red. And then I would probably go to the hydrogen and I would probably brighten the hydrogen to get a more intense yellow between the red of the sulfur and the blue of the oxygen. And the oxygen might even want a little bit of boosting, just trying to keep color contrast, because if you don't have contrast, you don't have any detail. And then the last thing I'll do is save this. And I'm not going to flatten it. I'm not going to do anything to lose the non-destructive editing. So I'm going to go to File, Save As, and I'll save this in my 2024 Photos folder. And I'm going to save it as a large document format. And this is going to be titled something like since this is a customer's data, I'm showing how to process it, but beyond that, I'm not going to do anything with the image. The data belongs to him. It's up to him to use it however he wants. I don't share his data with other people, and I don't share other people's data with him. So, if you do an hourly rental, the data that you're hiring us to collect for you is data for your exclusive use. So I try to make it feel like you're borrowing a friend's telescope rather than someplace where you just go online and order a data set of some target. Not that there's anything wrong with that. This is just the way we operate here at Utah Desert Remote Observatories. And with that, that's probably a good place to stop. I hope you found this useful. If you have any questions, obviously drop them in the comments down below, and I'll try to answer them as well as I can. And if you are interested in collecting your own data of some special target, you can reach us through the contact page on our website at utahdesertremote.com. It's a great way, kind of like Jim's doing here. He's done color imaging, and this is his first foray into monochrome. It's a good way to try it out and see if that's really what you want to do. I will warn you though, once you start doing monochrome, you won't want to go back to one-shot color, because monochrome is so much more flexible and gives you a lot more. So with that, I hope you have a great day today and an even better night tonight under a clear, dark sky. Thanks.